Terrestrial monitoring is very difficult and often really narrow in focus and quite expensive. Environmental DNA is a way of getting a lot of biodiversity information in a relatively cost-effective manner. So our project is trying to use environmental DNA to try to capture more biodiversity information from the ecosystem. eDNA is the DNA that's shed by all living things into their environment, and we can capture that information by extracting their DNA from samples, and those can be things like soil or air or swabs of vegetation. Most eDNA work has been done in aquatic systems, and in terrestrial systems it tends to be a little bit more difficult because the DNA distribution is patchier. So that means acquiring all of that DNA or getting the right sampling strategy to get representative samples is more challenging. So the first stage of our project is to try to get a sampling protocol that generates reproducible biodiversity information that represent the ecosystem that they come from. Our goal for this first stage is to get sampling that doesn't require cold storage, doesn't require equipment, and also, but probably most importantly, that they're able to distinguish between different land uses. Things like mining and pastoralism, and for residential areas, for towns. There's a lot of different land uses, and we don't fully understand all of their impacts on the environment. The second stage of the project is basically use all of that biodiversity information that we've collected and try to get meaningful metrics about the ecosystem from that data. So things like how many invasive species are there, do you have rare species, but also potentially looking at other algorithms that can help us understand the ecosystem health better. And that can really help for industry for things like monitoring your restoration, doing your baseline surveys, and ensuring that your rehabilitation is meeting its completion criteria. To improve our environment and our conservation goals, we need more information, and this is a tool to get some of that information. We're trying to simplify terrestrial eDNA monitoring so that it can be more widely applied by anyone who's interested in the biodiversity around them.